Let us look at some coordinate geometry questions review. The first one here. I want you to write an equation of a line that's perpendicular. So as soon as you see the word perpendicular, here I want you to think about the slopes. What about slopes? Slopes has to be negative reciprocal. All right, bisector means the midpoint. So those are the connections which we have to use. So let us try to look at these things together. So what if you had to say 3 comma negative 1, 3 comma negative 1 right over here, and then 3 comma 5. Then what we want to do is first find the slope between those two. Slope has to be, you can see that it's a vertical already, but we're just going to do the calculation here. y2, which is 5, minus y1 over x2 minus x1, which is 3 minus 3. So we'll end up getting 6 over 0. Now, the slope of the line that's perpendicular would have been negative reciprocal of that, so negative 0 over 6, which will be equal to 0, because when the numerator is equal to 0, in the fraction, the entire value equal to 0. How about the midpoint? So 3 plus 3 divided by 2, those are 2x values. Y values are 5 plus negative 1 over 2. So we end up getting 3 comma 2. 3 comma 2 is right over here in the middle, and that will be the midpoint between those two. So I'm going to have a perpendicular line cut to the midpoint. So we end up getting y minus 2, 2 came from here, times the slope, which is equal to 0, x minus 3. That would have been our answer. But the thing is, because you see 0 times whatever number that you get will always be equal to 0. So you can cancel them out as 0. Then we'll end up getting y minus 2 must be equal to 0. By adding 2 to each side, we get y equals 2. That becomes the equation of the line that's perpendicular bisector. How about number 2? Once again, perpendicular, it means I'm going to find the slope. Bisector means I'm going to use the midpoint. Then let us try to set this one up one more time. So negative 1 comma 1, and then 7 comma negative 5. 6, 7, negative 5, 3, 2. So if I were to connect these two line segments, it would have been something like this. So what is the slope? Slope is negative 5 y2 minus negative minus 1, which is y1 over 7 minus negative 1, which will be equal to negative 6 over 8. Now, yes, you can simplify this one as negative 3 over 4. But what is the slope that's perpendicular to that? Then it'll be negative reciprocal of it, so we get 4 over 3. That is a slope that's perpendicular to given the 1. Now, how about the midpoint? Midpoint is x1 plus x2, so negative 1 plus 7 over 2, and then 1 plus negative 5 over 2. Then here we get 3, comma here we get negative 2. So 3 comma negative 2. Oh, you can see that that must be the midpoint. Then, what is the equation of the perpendicular bisector? Y minus negative 2, which comes from here. Slope is 4 over 3. And then x minus 3. That would have been my answer. But if you wanted to combine negative negative into positive, so we could write down x plus 2, which is equal to 4 over 3 times x minus 3. And that would have been another answer. Alright, let's look at number 3. A triangle ABC has coordinates such as these. Find the perimeter. Now, you see, when we see the word perimeter, we are talking about the distance. And then we have to add up everything. So, once again, and negative 6 comma 2, and that is point A. Point B is negative 3 comma 6. And C is 5 comma 0. And then if you have to connect them, okay. So let's try to first find AB. What is the length of AB? So that is square root of x2 minus x1. So negative 3 minus negative 6 square plus y2 minus y1. So we get 6 minus 2 square. So what is negative 3 minus negative 6 square? That's right, it becomes 9. Because negative negative makes that into positive. 6 minus 2 equals 4. Square becomes 16. So which becomes square root of 25. We know that to be equal to 5. So how about BC? BC is, once again, x2 minus x1, so negative 5, negative 3, minus 5 square, plus 6 minus 0 square. Negative 3 minus 5 becomes negative 8. When you square them, it becomes 64. And this, of course, becomes 36. So we get our answer to be 100, which can simplify it as 10. Last line segment, AC. So here, negative 6 minus 5 square, and then 2 minus 0 square. So here we get square root of 121 from the first one, which is 11 square, plus here we get 4, which means we have square root of 125. Now how can you simplify that one? That's right, that's equal to square root of 25 times square root of 5. That's how we can make 125, but square root of 25 is equal to 5 square root of 5. So I think we found all three sides. But notice the first one was 5, second one was 10, so we can add them up together. It's not a big deal. How about the third one? That's right, it has a radical. So therefore, we cannot add up this one with the others. So our perimeter simply becomes 5 plus 10 plus 5 square root of 5, which will be equal to 15 plus 5 square root of 5. That is our perimeter. All right. Let's move on to the next question. So we want to prove that this triangle is isosceles. That means we need to show the two congruent sides. This allows us to use the distance formula. How about the right angle? Right angle, we're talking about this angle. That means perpendicular. So hence, slopes has to be negative reciprocal. All right, now. All right. So J is negative 4 comma 1, and E is negative 2 comma negative 3, and equals 2 negative 1. So if I have to connect them together, it looks like some sort of isosceles triangle, and then it looks like a right triangle as well. But we need to prove that. So how are we going to do it? Did you realize that the this portion seems to have a right angle? Then, guess what I'm going to do? I'm going to find the slope for JE. Let's look at it. So you get 1 minus negative 3. And then change of x, which means negative 4 minus negative 2. Then here we end up on the top, we get 4. On the bottom, we get negative 2, which is equal to negative 2. How about slope of NE? Then change of y, so we get negative 3 minus negative 1. And then the bottom becomes negative 2 minus 2. So on the top, we get negative 2. On the bottom, we get negative 4, so we get 1/2. You see how the slopes are negative reciprocal to each other? So we know that we can say that it's a right triangle. Next, we can say line segment JE must be congruent to EN because they look about the same. So to show that it's a isosceles triangle, we'll be using the distance formula. So what is JE? So negative 4 minus negative 2 plus y values 1 minus negative 3. So here we get, this one is negative 2, square becomes 4. Here 1 minus negative 3 becomes 4, square becomes 16, which is equal to square root of 20. And how about EN or NE? So 2 minus negative 2 and then negative 1 minus negative 3. Then the first one becomes 16 because 2 minus negative 2 becomes 4, squared becomes 16. How about the second one? This one simply becomes 2. 2 squared becomes 4. So we get square root of 20. And we know that it matches here. So we can write it as, since JE is congruent to NE and JE is perpendicular to NE, as we have seen from calculation, triangle JEN is an isosceles right triangle. All right, so that's how we can do number 4. Number 5. In this case, since we only see the word isosceles, that means we just have to do the distance formula. So let us try to plot this one first and see what we can do with it. 2, comma 1. That's A. 6, comma negative 2. And then C is 2, comma 6. All right, there we see. So if I want to connect, use the line segment to connect it. It would be something like this. All right, so here it goes. It looks like this line segment seems to be the same as this line segment, so we'll see what happens. What is AC? Since AC is vertical, we can count the boxes if it's vertical or horizontal, we can do that. Or if you want, you can put that into the formula here. We get between A and C. So we get 2 minus 2 square plus 6 minus 1 square. Then 2 minus 2 becomes 0, and then 6 minus 1 becomes 5 square, and then taking the square root, we know that the answer will be equal to 5. How about AB? So here we have 2 minus 6, and then 1 minus negative 2 square. Then here becomes negative 4 square becomes 16, plus here negative negative becomes positive, and then it becomes 1. It becomes 3, square becomes 9. So we get square root of 25, which later becomes 5. And notice that these two sides are equal. So we can say since AC is congruent to AB, triangle ABC is isosceles. All right. So let's look at the next question, number 6. Here we have, actually triangle, I meant ISA. A is right triangle. Because this is right triangle, what are we going to use? We're going to use the slope. Let's try to plot that triangle first. I is 1, comma 1 here. S is 3, comma negative 2. And then A is 7, comma 5. All right, so that's A, that's I, and that's S. And we'll try to connect the dots. So, which two sides seems to be perpendicular? It seems to be IA and then IS. So then let us try to find the slope. So slope of IS is 1 minus negative 2 over 1 minus 3. And here we end up getting 3 over negative 2. How about the slope of IA? So here we get, in terms of y, 5 minus 1. And in terms of x, 7 minus 1. So we get 4 over 6, which is equal to 2 over 3. And notice that slopes are negative reciprocal to each other. So therefore, since IS is perpendicular to IA, triangle ISA is a right triangle. All right, so we're gonna stop here for now, and then we'll continue in the part 2. I'll see you soon. Bye-bye.